Hi, this instructional video is about permutations. Permutations. It's part of the accounting principles. Statistics, that is. So, here's how it works. Permutations, well, what does it mean? You know, you ever watch those superhero movies where this one superhero, when he was a normal person, he was like either he got injured or bitten by a bug, and his genes got mutated. Mutated means his DNA structures have changed. And that's what permutations means. It means the order of the objects have changed. So, in this case, number 1, event 1, 8 ways. Event 2, 3 ways. And the question is, or the direction is, find the number of ways all of the events can occur. For example, event 1, I have a choice of 8 different soups. Event 2, I have 3 different choices of sandwiches for lunch. So, what are the possible combinations I could have? Oh, that's a bad word. I should not say combination. What are the possible choices of lunch combo that I could have? This soup with that sandwich, or that soup or with this sandwich? To figure that out, it's so simple. Check this out. The first choice, the first event is 8 choices times the second event is 3 choices. All you do is multiply. You have a total of 24 different ways of having this lunch. That's it. So now you just have to figure out number 2 and 3. Alright, on this one. Hey, can we make this like a soup? 3 different choices. Sandwich, 7 different choices. And ice cream cone flavors. Oh, not just the cone, I mean the ice cream flavors. 9 different choices. Yeah, why not? So you say 3 times 7 times 9 to get your special lunch combinations or combos. So that's going to be 3 times 7 is 21. 21 times 9 is going to be 189. So there's 189 different ways of having this lunch. And finally here, 14 people enter a race, and no one's going to tie. How many ways can the first and the second place come out? Well, the first place, all 14 people have a chance. That's the first event. First event is the first place, the gold medal. The second is going to be the silver medal. And now if one person won out of the 14 runners, then we only have 13 people who has a shot at the silver medal. So that's it. 14 times 13, that's going to be 182. So there's a total of 182 possible ways that first and second place can be placed. So there you have it. This is the classic license plate problem, where a license plate in many states, they are made up of, in this example, it says 3 letters and 3 digits. Unless you have one of those vanity plates, you know, love me license plates. Many license plates have some numbers or letters assigned and digits assigned. In this case, 3 letters. So the first 3 are letters. And then the last 3 are numeric digits. And in the English language, there are 26 letters in the alphabet. And the question is, oh, and of course, the Arabic numbers is 0 to 9, so it's 10 digits. Okay, now it says part A. If these numbers, these digits and letters can be repeated, I mean used over again, it could say like C, 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 and 777. If it can be repeated, how many possible ways are there to arrange a license plate that would have 3 letters and 3 digits? So let's think about this one. So if we have 3 letters and 3 digits, the first one, we have a choice of 26 letters. The second, also, if we repeat, another 26, and then another 26, followed by the 3 digits And if we repeat the digits as well, we have 10 digits, 10 digits, and 10 digits. And the way we find the possible number of choices we have is multiply them all. To make your life easier, let's use a calculator. So we have 26 raised to third power. That's going to be 17576. Times 10, 10, 10, that's 1 with 3 zeros. So that's a base 10 rule, so that's going to be 17576 with 3 zeros. So that means we have 17,576,000 possible ways of arranging our license plate for each of the letters and digits. If this is repeated, that is, if we're allowed to repeat. Now, if we use it once, for example, we use the letter A, and you cannot use it again for the second one, then the part B is saying, if they are not repeated, how many possible ways can we arrange this? Then that'll be, well, the first choice is 26. Then if we took the first letter out, we'll never use it again. Next one is, you only have 25 choices. And then 24. Same with the letter. If we use like number 1, then since we cannot use number 1 anymore, it'll be 9 numbers available, or 9 digits available. Oops. 10 first, and then 9, and then 8. So we then multiply them along. We get 26 times 25 times 24, and multiply that to the digits of 10 times 9 being available for the second choice, and then 8 being available. Total of 11,232,000 possible choices if this is not repeated. Repeat. There we go. All right. It's all wrong. So now, why don't you try to figure this one out? How many possible ways if you had 2 digits and 4 letters and you're allowed to repeat them? And part B, if you're not allowed to repeat them. What do you think? All right. So this time you said, all right, well, let me draw the boxes too. The first choice is 2 digits. This time is numbers, followed by letters. 1, 2, 3, 4. So if we repeat, we have a choice of 10 digits, followed by another 10 digits, which will make it 100. And the letters are 26 letters in the American US alphabet. That's 26, 26, 26, 26. Let's do that in exponential way. 26 raised to 4th power. That's going to give me 4, 5, 6, 9, 7, 6. Base 10 rule says just add the zeros along. So we get 4, 5, 6, 9, 7, 6, 0, 0. So there are over 45 million ways of coming out with different license plates. Now, if you are not allowed to repeat them, then you will be 10, and then since we cannot use one more after that, it'll be 9 only available. Same with the letter, 26, 25, 24, 23. So the digits, we have 90 possible choices multiplied by all the letters, 26, 25, 24, and 23. That's going to be 358,800. Sounds like a phone number. And multiply that with 90. That gives me a possible choice of 32,292,000 way of arranging the license plate with 2 digits and 4 letters. There's that.